Okay, so we were just talking about NERDs, and we're going to keep using that when we talk about what are called concentrations. Hang on. All right, so my guiding question here is, can we produce a voltage when the same metal is used for both half cells? So like if I had copper and copper, or nickel and nickel, like I'm going to show in this example, and the answer is yes. Okay, if you use different concentrations, now if they're the same concentration, it's not going to happen. But if you use different concentrations, those concentrations actually want to even out, like the whole equilibrium system. Okay, so electrons are actually going to flow in one direction to make it happen, and that reaction is going to be spontaneous until those molarities even out. So my example here is nickel. Okay. If I have a 1 times 10 to the negative third molarity here and a 1 molar here, essentially those concentrations want to even out. So electrons are going to flow in a way that makes it so this concentration or molarity is going to decrease, and this concentration or molarity is going to increase. So essentially, this side needs to make more Ni2+. It needs to make more aqueous. And this side needs to get the aqueous to turn into solid. So one is being reduced and one is being oxidized. Okay, so the one that's trying to make more nickel 2+ is going to be going from nickel to Ni2+, which is oxidized. So this is the anode. The lower concentration is the anode. And then the cathode would be the higher concentration because it's trying to get reduced. Okay, it's trying to go from solution to the metal. So the electrons are flowing this way from the anode to the cathode, like always. Still need my salt bridge. Okay, so this is going to happen, and I'm going to get a voltage for this as long as the concentrations are different. Now, eventually, the concentrations are going to even out. I get 0.5 and 0.5, and I have 0 voltage. Okay, so as the reaction occurs, those reactions are going to decrease, and then no more voltage. But if the concentrations are different, you can make an electrolytic, or sorry, not electrolytic, a voltaic or a galvanic cell. All right, so using the Nernst equation, we can calculate this. What we do, though, is since the E naught cell, since they're the same metal, there's no reduction difference. It's just that the E naught cell is 0. Okay, so you would do E cell equals 0 minus 0.0592 over N. In this case, it was 2 electrons, log of Q. Now, the reaction, you can write it out and balance it out, whatever you want to do, but it's always going to be the low concentration over the high concentration. Now, if you do it the other way, you're just going to get a negative voltage, and that's not possible. So just put the low over the high concentration. So what I have in example number 8 is a sketch and calculate the cell EMF, or the nut cell, of a concentration cell made between copper 1 molar and copper 1 times 10 to the negative 4th molar. Now, if I want you to draw this, I want you to tell me which one is the cathode, which one is the anode. You should have electrons flowing. You should also have a salt bridge. So that's what I have here. Okay. Now I have, I should have labeled these as anode and cathode. Oops. Okay. Well, semantics are that this would be the anode and this would be the cathode. But essentially, I have electrons flowing. As long as you show which way the electrons are flowing, you're good. From the lower concentration to the higher concentration, so that this one can be reduced and this one can be oxidized. So if I calculate this, I got 0 minus 0.0592 over 2 electrons, because it's copper 2+ going to copper, log of low concentration over high, I get 1.18 volts. Okay, now why are these important? Why do we make concentration cells? These are actually really great. That's exactly what we have going on in pacemakers. So in pacemakers, we use the potassium difference inside and outside of the actual pacemaker, not the actual pacemaker, but like 2 different parts of the pacemaker. The inside is 135 millimoles and the outside is 4 millimoles. So that difference causes electrons to flow, and that's how we power the pacemaker. We get 94 millivolts, which is all that you need, and we can actually measure that with an EKG. Okay? We can also use this not only in pacemakers, but to determine very, very small K values for Ksp specifically. Okay, so things that are dissolved in solution. So we can figure out what is the voltage, and that'll tell me how much stuff is in the concentrator in that solution. So what we do is we use the cell voltage and the Nernst equation to, instead of solving for what the voltage should be, to solve for what the concentration is. So it's just kind of working backwards of what we did. Okay, so silver. AgCl is a very insoluble compound. So I want to look for the Ksp of that. So what I do is I set up this concentration cell with a saturated solution on one side. Okay, that's going to be KSP, right? Because it's saturated. So for AgCl, KSP is Ag times Cl. Okay. I got my cell bridge, I got my voltage, I got my electrons transferring, and then I make the other one 1 molar just for ease of calculations, okay, of just silver. There's no chloride in here because if I put chloride in here, it'd make a solid. I don't want that. Okay, and so I've got the voltage going through here, and I got a voltmeter so I can measure the voltage. Okay, so you measure the voltage and you plug it into the equation. Okay, so what I did here is I first wrote out my KSP equation because I'm going to need that to calculate Q, right? Like this Q down here. And like I said, we made 1 molar silver over here for ease of calculation. Oh, we also make it 1 molar of chloride ions over here. Again, to make my calculations easy. Because if I know that the chloride concentration in this solution is 1, then I can just plug 1 in to my Q value. Sorry. Okay, so I've got my Nernst equation over here. I have my measured cell voltage, which is E naught, not E naught cell. Sorry, not E naught, E. Okay, I measured that as 0.576. So that means stuff is flowing. So I have some concentration of silver on that left side. Okay. Now the E naught cell is 0 because they're both silver. This is a concentration cell. Minus 0.0592 over 1. This is just Ag plus. So I only have 1 electron being transferred. And then log of, now how do I calculate this? I've got my low concentration over my high, remember, for silver. Okay, so low is just silver. That's what I'm trying to solve for. And high is the 1 molar. That's this one over here. Okay, so I'm just going to reiterate where all of these numbers came from. This is the measured voltage. This is 0 because it's a concentration cell. Do 0.0592 over 1 because 1 electron is being transferred. And since this is a concentration cell, it's the log of the low concentration over the high. This one is 1 and this one is the low. That's what I'm trying to solve for. So we can then very easily solve for this is essentially our X value. And you get that the concentration in the concentration cell is 1.9 times 10 to the negative 10. So I know the silver concentration. Well, the goal is to actually find the KSP. And if KSP equals Ag plus times Cl minus, well, I made my Cl minus 1 molar to make my calculation easy, then that is just the KSP because Ag plus is going to equal my KSP. So I found via this setup that my KSP is 1.9 times 10 to the negative 10. Okay, so use this kind of method to do example number 9. Pause it here. Okay, so walking through this example, okay, I wrote out my KSP equation. Okay, this is for lead sulfate. I've got lead and sulfate. I'm trying to find the KSP. So I'm using one cell that has lead 1 molar. That's my high concentration of my concentration cell. And the other has PbSO4. Okay, so that's the thing I'm trying to find KSP for with 1 molar sulfate ion. So I really need to find this lead concentration that is going to be my KSP, just like I did in the example before. So what I did is I first measured the E cell. I got 230 millivolts, which is 0.230 volts, right? Milli just means 1,000. Okay, so I converted that to regular volts. I did 0.230 volts equals 0 because it's a concentration cell, minus 0.0592 over 2 electrons being transferred because this is lead 2 plus, so it'll be going to lead solid, times the log of low concentration over high. The low is what I'm trying to solve for. Did my algebra, got that the lead concentration is 1.7 times 10 to the negative 8th molar, which means that KSP is 1 times 10 to the negative 8th molar over here because the sulfate is 1. So KSP and my lead concentration are the same in that case.